Hello guys, welcome back. Today we're going to start to talk about hypothesis testing, one of the most important topics in statistics. In hypothesis testing, we are testing for statistical significance. For instance, if we are claiming that there is a difference between two groups, we have to find enough statistical evidence to conclude that the differences are truly significant. Okay? So we will be talking about null hypothesis and the research hypothesis for a start. Before you start your research, you have to define your null hypothesis and the alternative hypothesis. So in this particular lecture, we're going to be defining those. We're going to be talking about types of tests, whether it's left-tailed, right-tailed, or two-tailed tests. We'll also be looking at type 1 and type 2 errors. Okay. So let's do some illustration with some of these with these three examples. We have example number 1. The mean monthly rent for an apartment is $800. A real estate agent believes that the mean rent is higher than this. So in this case, what we know is that the mean is $800. So that will form the basis for our null hypothesis. Then the real estate agent is believing that the rent is higher. So that will be what is going to form a basis for the alternative hypothesis. So in this case, we're going to have the alternative hypothesis saying that the mean is greater than 800. Okay. The second one, the boxes of cocoa are labeled as containing 18 ounces. So that's what we know for sure. So that's what our null hypothesis is saying, that it is 18. It hasn't changed. Okay. But there is an inspector who believes that the mean weight may be less than 18 ounces. So in this case, the alternative hypothesis is going to be pointing that there is indeed less than 18 ounces. So again, what we are trying to do is to gather enough evidence to believe that the mean is less than what it is, okay, or what is it has always been. Then the last one is talking about the mean height of women are known to be 5.5 feet. A physical trainer believes the mean height has changed. So in this case, changed. We don't know whether it is less or more, which means that it's going to be a different kind of test. So let's do the work out these examples using the table below. Okay. So you can see the very first example, the mean monthly rent for apartment 800. Then an agent is thinking that is the mean is higher this year. So this is how we write the null hypothesis. H0, have to write your null hypothesis. H0, the mean is equal to 800. That is what we know it to be. The alternative hypothesis is going to reflect a claim, a counterclaim to what is always there. So in this case, the alternative hypothesis is going to be talking about mean greater than 800 because that's what the real estate agent is believing it to be. Okay, so you can see the null, what it has always been, and the alternative is telling us what somebody is thinking it should be right now. Okay. So again, this is a right-tailed. This is one-tailed because if you look at the alternative hypothesis saying greater than 800, that's from the real estate agent. So it's right-tailed, which means greater than. Okay. Then the second one, the boxes of cocoa are labeled as containing 18 ounces, and the inspector thinks the mean may be less than 18. So in this case now, the alternative hypothesis is going to indicate less than. Okay. Again, remember the null hypothesis for most part is saying that it is what it has always been. It is 18. The alternative is saying is less than 18, which is what the inspector is saying. So because it's less than, we have it as a left-tailed test. Okay. So both the right-tailed and the left-tailed test are what we call one-tailed test. All right. If you look at number 3, you are going to see that is a slightly different from the two above. Okay, the height of women is known to be 5.5 feet. A physical trainer believes that the mean height has changed. So the key word is changed here. We don't know whether it's less or more. So we call this a two-tailed test because it could be less, it could be more. Okay, so this is how we write the alternative hypothesis. The mean is not equal to 5.5. Not equal to, which means it could be less than 5.5 or more than 5.5. So two-tailed. again the null hypothesis does not change. So you can see the simple ways we set this up. The null hypothesis HO colon the mean is equal to a stated value. Okay. The alternative hypothesis H1 1 as subscript colon and the mean is greater than the stated value. Okay. The decision of greater than, less than, or not equal to depends on what the statement that is made. Okay. So that's the types of null hypothesis and the types of tests. Now let's talk about some of the errors, common errors that are committed in doing null hypothesis in taking a decision about null hypothesis. We can reject the null hypothesis when it's true, and when we do this, we commit type 1 error. We can also fail to reject the null hypothesis when we should not. Okay. Now remember, if you find out that there's no significant difference, okay, then it means that the null hypothesis is true, so you fail to reject the null hypothesis. But if there is a significant difference, then you reject the null hypothesis. Okay, so let's illustrate with this example how we can commit these types of errors. Okay, so let's just say that the mean, the null hypothesis HO is the mean is 50, and the alternative hypothesis the mean is less than 50. Okay, so under what conditions do we reject, fail to reject, or take the right decisions? Okay, now we know that the mean is 50. So if we find out that the true mean is 50, then it means that the null is true. So we cannot reject the null hypothesis. Okay, if we reject the null hypothesis, we have taken a wrong decision, which is we're committing type 1 error because we're rejecting when we should not reject. Okay, now if we fail to reject the null hypothesis, okay, so let's say that the true mean is 40, which is less than 50, and we fail to reject that, then we're committing type 2 error. So this is presented in the table here. Now the mean, null mean is 50 and the true mean is 50. We are not supposed to reject because the null is true, but we have rejected, meaning that we have committed type 1 error. The second scenario, the mean, null mean is 50 and the true mean is 48. Okay, remember this 48 is what the alternative is telling us, and because it is satisfying the alternative hypothesis, we should reject. Okay, so if we reject, it means that we have committed no error, which means we have taken the true or correct decision. All right, the third scenario is where we have the null as 50 and true mean as 48, and we're supposed to reject because it satisfies the alternative hypothesis, but we are not rejecting. So because we are not rejecting the null hypothesis when we should reject, we are committing type 2 error. Okay, so these are just simple ways of illustrating when and how we commit type 1 and type 2 errors. Okay, so when we come next time, we are going to start to talk about the actual hypothesis testing using the z-score, talking about standard deviation known and standard deviation unknown. Okay, so till then, have a very wonderful time. Bye.